Okay, so we've done all of the variations, the direct variations and the inverse variations. We graphed them. We looked at joint variations. What we're going to do now is look at simplifying rational expressions, which is kind of an offshoot of an inverse variation situation. And we're also going to be multiplying and dividing rational expressions in assignment number 6. Let's go ahead and get started. So I'm going to simplify this rational expression first. So we've done things like this in the past. I'm going to first start with the numbers. I'm going to simplify negative 27 over 9. What number goes into 27 that also goes into 9? Well, it's 9 does. So 9 goes into negative 27 3 times. 9 goes into 9 once. So I'm going to have a 1 in the denominator. Then if I take a look at my x's, I have 3 x's on top, 4 on the bottom. So the 3 on the top will wipe out 3 on the bottom, and I'll have 1 x on the bottom along with 1 y. So this just simplifies to negative 3 over xy. Are there restrictions? Well, the restrictions are anything that makes the denominator equal to 0, because that means that we're dividing by 0 and we can't have that. So that means that x times y cannot be 0. Another way of writing that is that x cannot equal 0 and y cannot equal 0. Because if x is 0 or y is 0, then x times y is 0, which means we have an undefined expression. So let's take a look at one that's similar to that. How would we simplify something like this? Well, we're going to have to factor this and then cancel factors out. So for example, if I factor the numerator, I'm going to look for factors. So I'm going to start with maybe 2x times x, because 2x times x gives me 2x squared. Then I'm going to put maybe a 1 here and a 2 here, because I know 1 times 2 is 2, but I need one of them to be negative and one of them to be positive. So I'm going to check my inside terms. This is 1x minus 4x, and 1x minus 4x does give me negative 3x. So the numerator factors to 2x plus 1 times x minus 2. I'm going to do the same thing with the denominator. I'm going to have an x times an x, because that gives me x squared. Then I want something that multiplies together to give me 6, like maybe negative 2 and negative 3, and I want to make sure that what I picked also adds up to a negative 5x. This is negative 2x, and this is negative 3x, and a negative 2x and a negative 3x does multiply or add together to give me a negative 5x. So the denominator is x minus 2 times x minus 3, but you can see we have two common factors, x minus 2 and x minus 2. Those can cancel each other out. So what I'm going to be left with is 2x plus 1 over x minus 3. And does this have any restrictions? Well, that means, can the denominator be equal to 0? And it could if x was 3. So this is going to work for every situation unless the x value is 3. And so that's what our restrictions are. That's just a quick example of simplifying expressions. Let's take a look and see how this compares to something that's a little bit more realistic. What is the ratio of the volume of the cylinder to the surface area of the cylinder? Well, let's start with some formulas. The volume of a cylinder is the area of the base, which is pi r squared, times the height. Well, in this case, the height is r. The surface area is 2 pi r squared. So we have the radius of the base times 2, and then we have the radius of the base, or the circumference of the base times the height. That gives us the lateral area. So when we are looking to find the ratio, we're going to take the volume over the surface area. So the volume in this particular cylinder is going to be pi times r squared times the height, which is r, over the surface area, which is 2 times pi r squared plus 2 times pi r times the height, which in this case is r. So I'm going to rewrite both of these a little bit different. The numerator I can write as pi r cubed. The denominator, since this is pi r squared, just like this one is pi r squared, I have 2 pi r squared plus 2 pi r squared. Well, that's 4 pi r squareds. Well, that means the pi's cancel each other out. These two r's wipe out 2 of these r's, and I have an r on top and a 4 in the denominator. So the ratio of the volume over the surface area is going to be the same thing as r over 4 if we simplify it. Okay, so let's start multiplying some of these together. We know that when we multiply fractions, like if I took 2 over let's say 6, and I was multiplying that times, let's say 12 over 4, I could take 12 times 2 and 6 times 4 right away, or I could cross cancel some things, like 2 and the 4 could become 1 and 2. The 6 and the 12 could become 1 and 2. And then it's just the 2 and the 2 could become 1 and 1. And 1 times 1 is 1, 1 times 1 is 1, and I just have 1 as my answer by cross-canceling things. That's what I'm going to do here. Instead of multiplying a squared minus 4 times a plus 1, I could do that, but I want to simplify this if I can first. I'm going to factor a squared minus 4 to a plus 2 and a minus 2. Then I would multiply that times a plus 1. So I really have 3 factors on top. On the denominator, I'm going to take a squared minus 1. I'm going to factor that to a plus 1 times a minus 1. Then I'm going to factor an a out of here. That's going to be a times a plus 2. A times a is the a squared. A times 2 gives me the 2a. So now I'm going to look to see what I could cancel out. A plus 2 cancels out with a plus 2. A plus 1 cancels out with a plus 1. And I'm left with a minus 2 in the numerator, and then a times a minus 1 in the denominator. Are there any restrictions? Well, there are. A cannot be 0, and a cannot equal 1, because if it does, then I have a denominator that is equal to 0, and I can't divide by something that's equal to 0. And so that's my solution. Let's take a look at one more together. Here we're going to be dividing, and so I'm going to start with the first fraction. I'm going to factor the first numerator. So I'm going to take this a squared plus 2a minus 15. I'm going to write it as a times a. And I know that if I add a 5 and subtract 3, then 5 times negative 3 is negative 15. But then 5a and a negative 3a gives me positive 2a. Well, if I factor the denominator of the same fraction, that's this part right here, I'm going to have a times a and a positive 4 and a negative 4 multiply together to give me the negative 16, but they add together to give me nothing in the middle. So I'm going to multiply this by the reciprocal. So when I'm dividing by a fraction, I can multiply by the reciprocal. So that means that the top is going to be the 3a minus 12, but I'm going to factor out the 3, and it's going to be 3 times a minus 4. Because 3 times a is 3a, 3 times negative 4 is negative 12. And then in the denominator, I'm going to have the a plus 5. So now I want to see if there's anything that cancels out before I multiply all these things together. The a plus 5 cancel each other out. The a minus 4, those cancel each other out. And what I'm left with is 3 times a minus 3 in the numerator. And the denominator is simply going to be a plus 4. And so the restrictions are that a cannot equal negative 4, because if it does, then my denominator is equal to 0. So that's what we have for this video, and for our homework assignment, we're just going to be multiplying rational expressions and simplifying those expressions. Good luck on that. We will talk to you about that more tomorrow in class.